Friends, today we will try to calculate the lateral load carrying capacity of a pile embedded in cohesive bed. The method given by Davisson and Gill way back in 1963 is very popular technique to calculate the horizontal load carrying capacity of a pile embedded in clay. So we will see the method today. So the method is Davisson and Gill method, that is very popular. So we will see the method given by Davisson and Gill way back in 1963. The method for a horizontal load carrying capacity of a pile, say this is the pile which is embedded in cohesive bed and subjected to the horizontal force QG at the ground level. So at ground level, the horizontal force to this pile is going to be QG. Naturally, the pile is going to deflect, and if it is going to deflect, the deflection at various depth can be calculated. So let's say the deflection xz you want to calculate. So deflection is xz, horizontal deflection at any depth, due to horizontal load QG at ground level as shown in the figure. So Davisson and Gill gave a very good technique of calculating the value of xz. Xz is given by a coefficient Ax bar. This coefficient was given by Davisson and Gill. I will tell you how you can find it out. Into Qg R cube divided by EI for the pile material plus another coefficient Bx prime into Mg into R square divided by EI for the pile. This is the one equation that is given where Qg is this one. And if this pile is subjected to a moment at the ground level, say it is mg, then the equation 1 holds good, and xz is the deflection at any depth, where Ax prime, Bx prime are the coefficients, and these coefficients can be found out by calculating capital Z. This capital Z equal to depth Z. Depth in the vertical direction is a small z. So depth divided by capital R. What is this R? R is called relative stiffness factor. And this can be easily calculated as fourth root of EI of pile material, flexural rigidity of the pile material, multiplied by K. So by knowing the value of Z, capital Z, you can find out the coefficient Ax bar and Bx bar for the deflection. And EI is the flexural rigidity of the pile material, E is the modulus of elasticity of the pile material, I is the moment of inertia of the pile material, and K is called modulus of subgrade reaction. The modulus of subgrade reaction, its unit is going to be kilonewton per meter square per meter or kilonewton per meter cube. This modulus of subgrade reaction can be easily found out by knowing the Young modulus of the soil, ES, divided by 1 minus Poisson's ratio of the soil whole square. This is given by Basic in 1961. So Basic expression is widely used, and the value of K is also given by different researchers for clay bed. So different clay consistency. The clay is very stiff, hard. You can find out from the table the value of K, or you can calculate from this expression. You can also find out the moment along the length of the pile, that is mz. So along the depth of the pile, the moment induced can be also found out. This mz is given as a coefficient for moment m prime, which is again a function of capital Z, into Qz multiplied by R, plus, I will write it little below, this mz moment along the pile length is given as am prime coefficient into Qz multiplied by the value R, plus another coefficient, that is Bm prime into moment, external moment applied at the ground level. So here these are the coefficients. Qg as shown in the figure is the force, mg as shown in the figure at the ground level. This expression. So if horizontal magnitude of the horizontal force is known to be, and if the dimensions of the pile and material of the pile are known to be, I can find out the deflection, I can find out the moment along the pile's length. Or if the permissible value of the deflection is given to you, you can calculate the horizontal load capacity of any pile. So equation 1 and equation 2 are very, very important, and in the next slide we will see how to calculate, in the next video we will see how to calculate the horizontal load carrying capacity of a pile, or if you want to calculate the moment, how to calculate it. Thank you very much.